let's get into some non-normal cases of indifference curves, which is good, bads, and neutrals. We have drawn and explained the ICs of commodities which are goods, that is desirable objects. If a commodity is a good, then more of it is preferred to less. As seen above, ICs between two commodities which are goods slope downwards and are convex to the origin. However, when there is a consumer, a commodity is a bad, that is undesirable object, more of it will lower his satisfaction, right? Intuitive. Thus, if a commodity which is bad, uh, less is preferable to more, like pollution, risk, tenacious work, and illness are some examples of bads. In case of bads, ICs are of a different shape. Suppose a bad, for example, pollution is represented the x-axis, commodity which is good is represented on the y-axis, then ICs which are sloping upwards, that is, will have a positive slope, are displayed in figure 8.9. This is because in this case, a movement towards the right along the ICs implies more of pollution, which will reduce consumer satisfaction, and therefore, in order to keep his level of satisfaction constant, the quantity of commodity which is good, such as clothing, will have to be increased. Okay, so you have to increase clothing in order to give him more of pollution if you need to. Okay, more of pollution which will reduce consumer satisfaction. Therefore, in order to keep his level of satisfaction constant, the quantity of commodity which is a good, such as clothing, will have to be increased. So you will have to, if you have to increase pollution, you also will have to increase the amount of good that you're giving to that person, which is why these ICs are concave in shape. The direction of preference in this case is upward and to the left. Okay, um, upward and to the left, so less and less of pollution. So let's just say on this very point, let me just draw this. Okay. Yep. So at this very point, if you see, you just have to give him more and more of good x, so the direction basically is up and to the left. Okay, an important applicant of indifference curve analysis in recent years relates to the problem of portfolio selection. Portfolio selection by an individual means his choice of a particular distribution of his wealth among the several assets such as equity, shares, debentures, real estate, etc. These different assets yield different rates of returns and involving varying degree of riskiness. In the analysis of portfolio selection, the average or mean returns from the portfolio enters as a good or a desired object, whereas degree of risk involved enters as a bad or an undesirable object. So average return is a good, riskiness is a bad, and if you are plotting the bad on x-axis in both of these cases and good on the y-axis. 8.10, we depict ICs of an investor who wants or prefers higher rate of return and low risk. So lower risk and higher rates of returns, like I just depicted here as well. The higher the average return, the higher the neuter. One commodity can be a neuter or neutral good, in which case the consumer does not care whether he has more or less of that commodity. So is basically indifferent about how much amount of that commodity is going to have. That is, more or less of a neuter does not affect the satisfaction in any way, because it's a neutral, right? It's neither a good nor a bad, so more or less of it is basically not mattering to the consumer at all. If a commodity X is a neuter good and Y is a normal good, X is a neuter, Y is a good, so you would want more and more of Y, but you are just indifferent between the amount of commodity X that you want. Satisfaction of an investor, and higher the risk of involved in the portfolio, the lower the satisfaction of the investor. Therefore, in this case also, the indifference curve between riskiness, bad, and rate of return slopes upward. This is because as we move rightward, satisfaction declines due to higher rate. To compensate this, I think there has been some kind of misprint, because higher the satisfaction, this has to come here. Okay. Okay, let's just discuss this for once more, but yes, this has to be sort of concluded in this very way. Let me just check if we are So if commodity X is a neutral good and Y is a normal good, uh, Y is a normal good, we will basically have horizontal ICs, okay, because more of good Y, good is more and more, and for X you're basically indifferent, okay, which is why it's going to be a horizontal line. Let's come back here. So in figure 8.10 we depict ICs of an investor who wants or prefers higher average rate of return and lower risk. So the average rate of return has to be greater and greater, and the riskiness that you want is has to be lower and lower, so leftward and upward is the direction. That's how you can determine basically. The higher the average return, the higher the satisfaction of the investor. So higher the average return, right, higher will be the satisfaction, okay, so we want to go up and up. And higher the degree of risk involved in the portfolio, the lower the satisfaction, so leftward is the direction. Therefore in this case also the IC curve between riskiness and rate of return slopes upward. This is because as we move right towards satisfaction declines due to a greater risk, and to compensate for the decline in satisfaction due to greater risk, satisfaction due to greater risk, and to keep the level of satisfaction constant, has to be increased. It may be noted that the direction of preference in this case will also be northward and westward, okay, north and west. And then ISCs will be horizontal, okay. Now this is basically the part from this, the neuter one, okay. Let me just color this another color, but this has to end here, and it should be it's understandable why it has to be northward and westward, okay. Now let's come back to this. If a commodity X is a neuter and Y is a normal good, then indifference curves will be horizontal lines depicted in figure 8.11, and the direction of preference will be upward into the north, indicating thereby that the higher level of indifference curve will mean the higher level of satisfaction, because upward movement will mean we have more of a good, like I just explained a while ago. The quantity of a neutral good remaining the same. So the quantity of that particular good is remaining the same, right? On the other hand, if Y is a neuter, okay, this is a neuter, while commodity X is a good, then it's quite intuitive that more of good and the same level of Y. Satiation and point of bliss. Our observation of the real world tells us the commodity can be a good only up to a point called the point of satiation. So basically, a good can be a good only till a given point. Okay, after that, there has to be a point of satiation where you become satiated and becomes a bad for the consumer. And after that, it becomes a bad for the consumer if he's forced to increase his consumption beyond that satiation point. There is a combination of bundles of commodities which contains the optimal or most preferred quantities of the commodity for a consumer, and any increase in the quantity of each of them beyond that best or optimal quantity will make the consumer worse off. So if you increase that the amount of that particular commodity, it's just going to make him worse off. Quantities of other commodities remaining the same. Now we're assuming that other quantities of other commodities are remaining the same. Too much of everything is bad. Therefore, commodity X becomes bad beyond the quantity X1, and commodity Y becomes a bad beyond the quantity Y1. So this is given to be your bliss point or your point of satiation. Okay. Two goods cases represented in 8.13, where the circular indifference curve between the two commodities X and Y are drawn. Suppose X1 and Y1 are the quantities of two commodities which a consumer considers the best or optimal quantities, beyond which the two commodities become bad. Okay. Point S represents at most preferred quantities of the two commodities and is therefore the point of satiation or bliss in zone 1. Okay. See this. Okay, the portion of indifference curve between the two commodities is negatively sloped. It's like this, right? It's just like a convex good, okay, uh, convex IC, okay, just like for two goods, and therefore the two commodities are good in this region, right? Like I said, uh, the ICs are convex shaped, just like and negatively sloped convex shape, just like for the two goods that we explained initially, the very general ICs that we explained, and so we can assume that both the commodities are good here, okay, because they've still not reached the point of satiation, right? Let us now consider point A in zone 2, which contains more of y than regarded optimal or best by our consumer. Therefore, in order to keep this satisfaction constant, he has to be compensated by an increase in x, because more of y. Okay, so you need to compensate that by giving more of x. Note that in zone 2 the quantity of x remains less than x1. An increase in quantity is desirable and adds to the satisfaction. In zone 2, ICs have positive slopes, and here, while commodity x is too little, the commodity y is too much. Therefore, in zone 2 the commodity y becomes a bad while the commodity x remains good. Okay, in zone 2 you see that y is a bad and x is still a good, so you still can get more of x. Okay, but you don't like, so you want to be compensated for that more of y that you're getting by more of x also. Okay, so here x is bad because it's greater than the point, greater than let's say here at a, this whatever point of y this is greater than y1. But if you check here at any point before x1, x is still less than x1, so x is still a good. Okay, it may be further noted that as the consumer moves towards the point S, or his indifference curve approaches closer to the point, his satisfaction is increasing, and at point S of satiation, his satiation is maximum. Satiation point S is also called the point of bliss. Now consider point R on IC1 in zone 3, in which the indifference curves have also negative slope. As the consumer moves from R to S, the quantities of both the commodities decrease, but he reaches nearer to the point S of satiation or bliss. In this case, both the commodities are bad. In zone 3, you see both of them are more than what is required. So they are again negatively sloped curves. The sum and substance of the whole matter is that as a consumer moves nearer to the point preferred to S, his satisfaction increases. So the both of them are bads, which is why we have a concave shape of the ICs. Okay, uh, since both of them are bad, the concave shape is actually um, like this. For this case, for example, it was like this, the concave shape was like this because one of them was a bad and the other one was a good. Okay, like you can see in this case, you'll be able to relate both of these cases now in zone 4, because commodity x is a bad now at this point and y is a good, same as this one. So you see that the curves are just like the ones that we depicted here. Okay, it follows from above that the consumer will have some optimal or most preferred combination of commodities, and closer he is to that combination, the better off he is. The combination of two commodities, say chocolate and ice cream, which are nearer to the point of satiation or bliss point, lie on the higher IC, and the combinations lying further away from the satiation point would lie on lower ICs. There will be some optimal combination of chocolate and ice cream which a consumer would like to eat per week. Consumers would not voluntarily like to consume too much of them, which is more than what they want when they both become bad. Thus, the interesting and relevant region for consumers' choice of commodities is where he has less than optimal quantities of both of these commodities, which is zone 1, in which the consumer has less of two goods than he wants, and therefore increases the quantities of two goods in his region, will cause increase in the satisfaction and will move him nearer to the point of satiation. So the best region where a particular person can be when he has a bliss point is in this region, which is why we draw the ICs to be like this always. Okay, so the closer he gets to the point of satiation S, the better off he is, so he can increase both of them, so we can have higher and higher ICs. That's it for today. Let's carry on in the next lesson.